We're going to talk about how graph can power machine learning. First of all, let's review some graph terms. In a graph, we have nodes. We also have edges. Nodes are entities. Edges are relationships. Relationships connect nodes. A graph can be either directed or undirected. A good example of directed graphs is tweets. A good example of undirected graphs is friends. With a graph, when we say neighborhood, we are talking about how to go from one node to another. In other words, how we reach a node in the graph. When we talk about distance for a graph, usually we mean how many hops it takes to go from one node to another. There are three typical use cases for graph data. We can query a graph. We can also use a graph for analytics or machine learning. In this diagram, we can see there is some overlapping between analytics and machine learning. Also, graphs can power both analytics and machine learning. When we do graph machine learning, we use graph data to do machine learning. With machine learning, there are two steps. First, we need to develop, train, and test a model. Once a model is available, we can use the model to do inference. There are two types of machine learning: supervised machine learning and unsupervised machine learning. Graph data can power both types of machine learning. With supervised machine learning, we work with labeled data. With unsupervised machine learning, we work with unlabeled data or raw data. We can also use graph data for advanced use cases, such as graph neural networks. When we do traditional machine learning, we work with independent data. When we do graph machine learning, we usually work with related data together. Here are a lot of reference materials that we can dive into if we want to learn more about graph machine learning. Lastly, we can go to this URL to learn more about what we just went over and some examples related to what we just went over. This is the end of our discussion.